Hello. In many embedded applications today, it's very popular to want to be able to update the firmware over the air. In order to do that, we have to think about some security issues, and you will probably want to put in place a secure boot and secure firmware update software. And what this video is going to show is how we're able to actually measure the structural coverage of this particular software. Now, here we have such a software. This has been written for this STM32 board, and we're using the embedded Workbench. And let's just go and build this. So, okay, it's already built, and now I'm going to download this to the target. So I've got a target connected to the board, to the PC at the moment. So let's just download this. That's erased the flash, and then it's flashed the program. So now let's run this and see what happens. So I've connected TerraTerm to a COM port, and I'm now going to press the reset button on the board. And as we can see, this is now executed. So what happened is we can see that the code started here from the reset. It's then initialized what it needs to do. And at this point, it's then done a reboot. And after the reboot, it's then restarted. And in this case, it's gone into a different mode. And then it's got to a certain point here. And now we're able to do whatever we want. We can download a new firmware image, for instance. But that for the moment is how this is working. And I want to be able to obtain coverage both before this reset and after the reset. So let's go into LDRay TV Vision. And inside here, I've already analyzed the code. And what I'm going to do is I'm going to tell the tool to perform the build. And here I'm going to tell it to do the build externally. And all I want LDRay to do is to simply substitute the source code with the instrumented code. So let's start this and let's go back into IR. And what we're going to notice after a certain time is the code will be substituted. And this will now show us the instrumented code. And there we have the instrumented code. So let's take a look and see what we've got inside here. I'm going to do a find, and I'm going to look for a function called upload execution history. Okay, so what I've done is I edited the instrumented code to find the place where it was going to do the reset. And the line just before, that's where I've put this call to upload execution history. So that will effectively send the data out over the serial port, and we can capture it and understand what code was executed. In case you're wondering what these are the probes that we're putting into the code. That's going to effectively tell us that we've executed this block of code here. Let's do another search for upload execution history. And if I do that, we can see that I've added a second call here. So at this particular point, we can see that this function should not return. And so I thought that's a good point to say, well, let's stop here and let's find out what code is executed up to this point. So again, I've edited the instrumented code to put in that call. Right, so let's go and now perform the build. So this time we're going to build the instrumented code. So I've only instrumented the code inside the application. I could have done it as well for the other files inside here. Okay, so we'll wait for that to be built. Okay, that's now built. So what I'm going to do is I'm just going to put the source code back here. And now I'm going to go and download just like I did before. So download the application. And there we can see it's flashing the target just the same as before. And once again, I should be able to go into TerraTerm and let's do a clear screen. And now I'm going to press the reset button again. And this time something quite different has happened. So what's this here? Well, okay, let's scroll up. And the first thing that happened is we can see that's what we had before. Here we've got the new reset. And then at this point, that's where it was going to call the reset. But before it's done that, it's sent the data out to the serial port. And I can effectively capture this data here. Let's capture that, put that into the buffer. And now I'm going to go and I'm going to save that inside here. In fact, I've already done it. So let's just open that and we can see that's effectively the same data that we've just captured here. So I'm going to go in and close this down and I'm going to copy this file and I'm going to put it into this location here. Okay, and now I'm going to go into LDRay and I'm going to tell it to analyze that particular history file. So we can see I'm going to do the dynamic coverage analysis, and I'm going to call this run, let's call it the before reset. And let's start that and start it. Right, so that's now going to start analyzing that file. And while that's analyzing, we can go back over here and we can see, if we scroll up, that that was the end of the data, and then we can see the code is rebooted, and then it's got to this point, and that's where it's called the upload execution history a second time. And this time we can take a look at the data and we can see these are effectively the probes and these are the files. So once again, I can capture this information, paste it into that file, and then we'll get it to analyze that file as well. So once again, to save time, I've already done that. So let's go into the after reset, and there we can see that's the same, slightly different values, but it's the same file. So once again, I'm going to copy this. Okay, and I'm going to put it into the same location as before. And now I'm going to go back into LDRay and tell it to analyze this file as well, and it will accumulate the results together. So this time, let's call it a after reset. So again, I can call these runs whatever I want. After reset. Okay, and let's start the analysis. So once again, it's going to do exactly the same. It's going to analyze that file. It's going to extract all the probes for each individual file. So we can see here that the SF boot was the file 271. It's analyzing those, accumulating the results together, and then we'll be able to get an idea of, well, what coverage have we obtained. So let's just wait for that to finish. And then we're going to be able to take a look at this test manager report. So just a few more seconds and we should be able to do that. Okay, so command line mode finished, that's good. So just wait to get the control back, and I'm now going to be able to right click on here and we can view a test manager report. So first thing is, let's maximize this. We'll scroll down. We don't care about the code review or the quality review at this particular point. We're more interested about the dynamic report. In this case, I'm just measuring statement and branch coverage, but if I wanted, I could also measure the MCDC. And we can see for sfboot.c, we've got some coverage. Let's take a look at that. So we can see that both our runs have contributed to get coverage, both the before reset and after reset. And if I scroll down, we can see, well, got some reasonable coverage. Still some functions where we've got no coverage at all. For instance, we've never had a critical failure. Well, that's good. And let's take a look at the first one here, SFU boot run secure boot service. Let's go into that. And we can see that both the two runs have contributed coverage. But at this point, we can see that the before reset executed this line of code here. And the after has executed this line of code there. So that's giving us the coverage both before the reset and after the reset. And if you'd like more information, then please don't hesitate to contact us at elderray.com. Thank you.